Hey guys, so we're moving on to the second part and the last set of notes for Unit 4. And this one's on graphing linear inequalities and then word problems involving inequalities as well. So reminders that come up here are that when you are graphing an inequality, when you draw that you have to graph the line like you normally would, but in order to figure out, you have to determine whether the line is dashed or solid. So remember, a dashed line right here is when it is the greater than or the less than sign. And a solid line is when you have the greater than or equal to or the less than or equal to. Then you also have to determine, based on the inequality, whether you are shading above or to the right, or below and to the left. So above and to the right are, if you have these two inequalities, those are the greater than inequalities. And then below and to the left is when you have these two, and that's the less than inequalities, okay? So when we are graphing the inequalities, we have to use these steps. We have to do these extra steps in order to be able to determine what a solution is to these, okay? So when you have that, if we look at the first set of graphs, it gives you the graphs of each of the equations already graphed for you, and then it wants us to shade each of the graphs below. So we have to practice what the shading would look like. So when we do the shading, we can do a couple different things. We could use a highlighter, or we could do what's called cross hatching. And cross hatching, you will see, will show where the overlap is. So in the first example, we have y is greater than or equal to 3x plus 7. I know that this is that this must be the solid line in my picture because of that inequality. So if I'm looking at the solid line in my picture, then I need to shade that line above, because above that line, or greater than or equal to, means to shade above. So what I'm going to do is I'm going to shade everything that is above that line, and above that line would be over here. Okay, so I'm going to shade in what's above that line. Then if I look at my next inequality, I have y is greater than negative 4x minus 3. Since it is greater than, I know that this is my dashed line, and it's also greater than, so I'm also going to shade that one above. That one should be shaded above as well because of the greater than symbol. So if I do that, I have all of the things that are shaded above this line would be all of these things over here. And then what I want to do is I want to look for the overlap. So notice that the overlap between these two shaded regions is this little V area right here. That would be where your solution would be. Okay, you could pick any number that falls within that shaded area, or any ordered pair that falls within that shaded area. For example, an answer to this one might be negative, geez, I think it would be like negative 2 and 6. That might be an answer to this set of inequalities. Okay, so let's try a couple more examples. So that was the shading way. Let's try the cross-hatching way, which is if you don't have any different colors for your paper, then you would probably want to do it this way. So in the first one, we have y is less than 2x minus 1. I know right off the back that that's going to be the dashed line in my picture, and less than means to shade below. So I know I'm going to shade below the dashed line. So if I do that, I'm just going to keep my red pencil here, and what I'm going to do is I'm going to shade below this line, and I'm just going to draw lines going at an angle to shade below those lines. Okay? And then if I look at my second equation, I have y greater than or equal to negative x plus 2. So I know that that's my solid line. And I also know that I have to shade above the solid line because it's greater than or equal to. So if I do that, what I'm going to do is I'm going to make my lines go in the separate direction for shading. I'm going to shade above the solid. And now my answer is going to be what the cross hatch provided, and that is going to be where they overlapped, okay? So their overlapping here happens where the blue lines crossed the red lines, okay? So this might be another way that you can do it. So I could pick any solution within this area, and that is considered the overlap of the two inequalities, okay? All right, let's try one more. So in the last one, we have y less than or equal to negative 3x plus 2. Now, since they both are equal to and they're both solid lines, I have to figure out which line this actually is. And I know that this is going to start at 2 because of the y-intercept, so I know that it must be this line right here, okay, that I just highlighted. So the less than or equal to, remember, means shade to shade below that line. So what I'm going to do is I'm going to shade below that line. I'm just going to shade everything that is below that line, which would be over here. Okay. So when I do that, now I'm going to look at the second equation. And in my second equation, I have y greater than or equal to negative 2x minus 4. And I know that greater than or equal to means to shade above. And I'm going to shade above my other solid line. And when I do that, you're going to be able to see the overlap. So we shade above here, that's everything above this line. And then you will find that the overlap, or the darker color between these, would be anywhere in between here. There's the darker color, and that's where the overlap is. Okay? So this can be tricky because you have to be able to see where the overlap is to solve these equations. So in the first example, it says graph the solution to the following system of inequalities, and the solution to the system of inequalities is where the shaded region overlaps. So let's do our graphing for this one. So in the first one, I'm first going to graph my lines. So in the first one, I have y y less than negative 4x plus 5. So before I even start graphing, I know that the less than symbol means I'm going to make a dashed line. I also know that it means that I'm going to shade below that line, okay? But I'm going to save the shading for last. So first I'm going to graph the line. Remember, it's in y equals mx plus b. So remember, your first step is to plot the b on the y-axis. And then your second step is to use the slope, knowing it means rise over run, to plot another point. Okay? So first thing I'm going to do is I'm going to plot my first point at 5, right there on the y-axis. And then my slope is negative 4, so I'm going to go down 4, right 1. And then from there, I'm going to make a dashed line because of my inequality symbol. So my best dashed line there. Okay? I'm going to hold off on the shading until I graph my second equation. So in my second equation, I have y greater than or equal to 2x plus 3. So I know right off the back that I'm going to make a solid line. I also know that this one is going to be shaded above because of the greater than or equal to sign. Okay? So if I go to graph this, I'm going to start with my first point at 3. And then I'm going to go up 2 over 1 because my slope is 2 over 1. And I'm going to make a solid line through those 2 points. Now that I've drawn my lines, I'm going to do the shading. So if I shade for my red line, I have to shade below. So I'm going to shade for my red line everything that is underneath it. And that's that. Okay? And then my solid line, my blue line, I have to shade above. So I'm going to shade everything above that solid line. And when I do that, I can see that my overlap between the two is all of this region right here where they crossed paths. Okay? So my job is to find an answer here, any number or any ordered pair that fits in there. So for example, if I pick this random point in my shaded region, that point is negative 5, 4, and that is a solution to your set of inequalities. Okay? So that's how you find an answer, by graphing. On the next one, they're asking us to graph again, so we're going to do another one and again give 1 point in the solution set. So we're going to do another graphing one to get the extra practice. And here's even more extra practice because these ones are not in y equals mx plus b. So we need to get them to be. So we need to get the y by itself. So that's your first step, is to get the y by itself. So for the first equation, I'm going to add the 5x to both sides so I can get y by itself. And then I'm left with 6y less than, I'm going to put the 5x out front so that it looks like mx plus b, and then minus 18 out back. And then my next step is to divide everything by 6 in order to get y by itself. When I do that, I now have y less than 5 over 6x, which is helpful to us because it is a slope, so that's fine. And then minus 18 divided by 6 is 3. There's our first equation, okay? So our first equation, or inequality, looks like this. Our second inequality, if we go to solve for y, first I'm going to minus the 2x from both sides, and then I'm left with 7y greater than or equal to, I'm going to put the negative 2x out front, minus 14. And I want to get the y by itself, so I'm going to divide everything by 7. When I do that, I'm now left with y greater than or equal to negative 2 over 7x, and then minus 14 divided by 7 is 2. So there's what our second inequality looks like in y equals mx plus b form. Now what we're going to do is we're going to graph them as we know how. So notice that the red line is going to be dashed because of that inequality, because our inequality is the less than symbol, and then we're going to shade below. Okay, so first let's make a dashed line and graph it. So I'm going to start at the negative 3 for my red line, and then my slope is 5 over 6, so that tells me to go up 5, 1, 2, 3, 4, 5, and over 6 till I plot my next point. Once I plot that second point, I can make my best dashed line that goes through those points. I'm going to hold off on the shading until I make my second line. So looking at the inequality symbol for my second line, it's greater than or equal to, so I know I'm going to make a solid, okay? And so I'm going to start with my first point at negative 2, because that's my y-intercept, and then it's negative 2 over 7 for a slope, so I'm going to go down to right 7, and I'm going to plot my second point. And this one's a solid line, so I'm going to make my best solid line that goes through those 2 points. Okay, now I'm going to do my shading. So less than or equal to in my first red equation tells me to shade below. So I'm going to shade everything that is below that line, okay, in red. The second equation, y greater than or equal to, tells me to shade everything above the blue line. So I'm going to shade everything that is above that blue line. And then you notice that my overlap is right here. That's where the two lines overlap in colors. And if I'm going to find a point solution, a point that is in the solution set, then I'm just going to pick a random point in there. So if I pick this point right here that lies right on the line, then that point is at 8, 0, and that lies in the solution set. That is a possible solution to this set of inequalities. Okay, so remember, you got to get it into y equals mx plus b first, then graph and shade last so that you can determine where the overlap is. And then the last set of problems in this particular unit are solving two-step linear inequalities in a word problem form, and then writing multi-step inequalities. So first, let's look at the word problem. In the word problem, it says, Kayla's fish tank has 14 liters of water in it. She plans to add 4 liters per minute until the tank has more than 46 liters. What are the possible numbers of minutes Kayla could add to the water? So we don't know. We always have to figure out what it is that we don't know in order to figure out what our variables are here. So Kayla's fish tank has 14 liters of water in it, and she plans to add 4 liters per minute until the tank has more than 46 liters. So if we go back to writing equations, okay, the way we used to write equations, we're starting with 14 liters in the tank. So that's how my equation is going to start, 14 liters. And then we're adding a slope of 4 liters per minute. And we don't know how many minutes it is, so we're going to put an M here. Then the key words here is that it says the tank, we are going to do that until the tank has more than 46 liters. Well, the term more than refers to the inequality greater than, okay? And it's not greater than or equal to because it didn't say greater than or equal to that number. It has to be over 46 liters. So the more than symbol would be the greater than symbol. So you'd say 14 plus 4m is greater than 46. This is our equation, and then they want us to solve it. So it's a two-step linear inequality. This is our inequality. Now we have to solve it because they want to know the number of minutes Kayla could add all the water. Okay, so what we're going to do is we're going to solve this like we would any two-step linear inequality. We're going to subtract the number 14 onto both sides so I can get my numbers onto one side. So then I have 4m greater than 32. Then I'm going to divide by 4, and I get a final answer of m greater than 8. So as long as m is greater than 8 minutes, that is when they could add the water. Okay? In the next one, we're writing a multi-step inequality, okay? So in the next one, we have Linda drives a truck for a soft drink company. Her truck is filled with 15-ounce cans and 70-ounce bottles. Let C be the number of 15-ounce cans the truck is carrying, and let B be the number of 70-ounce bottles. Okay, so we have our variables here, just right off the back. We have C is the 15-ounce cans. C stands for cans, and then B is the 70-ounce bottles that are in this truck. So the truck must be carrying less than, there's a key word there, less than 6,000 pounds or 96,000 ounces. Since the bottles are in ounces, this is important to note that we actually need to use the ounces amount over the pounds amount because the bottles are in ounces. Says using the values and variables given, write an inequality describing this, okay? So again, they're 15-ounce cans, and C is the number of 15-ounce cans. So if I'm going to write that they are 15 ounces, and we're going to do everything in ounces because these bottles and cans are in ounces, then I'm going to say the truck must be carrying less than that amount. So therefore, 15 ounces times the number of cans can be written as 15C. Plus, the truck also has 70-ounce bottles times the number of bottles that are on, which we don't know, would be written as 70B. And then the truck itself must be carrying less than, and the less than symbol is this one. The less than symbol is there. Less than 96,000 because we're going to use the ounces. So less than 96,000 ounces. That is what our inequality would look like. And all you have to do is write the inequality. You don't have to do any solving. So this all depends on looking at the word problem and what it states and then trying to interpret what it means using an inequality symbol. All right, so this is a little bit tricky and a little bit long. So as always, let me know if you have any questions, and good luck.